Mark P. Otten back with you. Welcome to your multiple regression in R video, or a regression with more than one independent variable. In this case, it will be two independent variables predicting one dependent variable, and it will match your video that you have posted on the website as well on how to do this in SPSS. This is the same data, the same example that I used in the SPSS video, and it comes from a data set that I collected a few years back on people's driving psychology. How I call it the road rage data. How upset do you get on the road? How do you ever enjoy it? If so, like how? Yeah. So it's an interesting thing to look at, especially here in Southern California, where people get frustrated on the road. So I'm a sports psychologist, but this was interesting data. So now I use it to teach class. Okay, so hopefully you're not driving the car right now while you're watching this video. Okay, well, I guess you could. You just listen. Don't watch the video because then you might get distracted or anyway. All right, so this is the data. I imported it. It should be on your class website for you to save and then import it yourself. So no data like format changes or anything in this case. It's a larger data set. You can just import it in, and then we're going to specify the right variables here in our code. Our code. Okay, anyway. So here it is. If you watched the one independent variable regression in R video, code looks very similar. We're just adding in a second independent variable, but this is different data. So I'll talk you through it a little bit here. The first line specifies model at the beginning. That's standard for regression. It's a regression model, a model to predict the dependent variable from, in this case, two independent variables. Then the left arrow followed by LM, which stands for linear model, parentheses. You've got your DV here, which is anger 8. The descriptions of these items are in your SPSS file and also in your SPSS video. But I chose that one as your DV. And then the IVs here are to the right of the tilde. The IVs are separated by a plus in the middle. We're not actually adding the IVs together. It's just, that's R's way of saying there's IV number 1, and then there's a separation, and then there's IV number 2. In this case, it's two items from the trait anxiety scale. This is real data. We had students at CSUN fill out these measures. How anxious are you? And then does that in fact influence your driving behavior or your attitude toward driving? Okay, so we'll find out for these particular variables. And then at the end of the term here or the line is just comma, data equals, and then the name of the data set. So road rage is what we have it called here. The summary term is summary, parentheses, and whatever you called it in the first line at the beginning. So summary, parentheses, model, $COEF, which is for coefficients, which is regression coefficients that the R program is about to give us. And then this, so then you could run it with these top two lines here if you wanted, but I like to include the last line because the last line also gives us our betas. The betas are the standardized coefficients, which are especially useful actually often in a multiple regression as opposed to a one IV regression. So what this does is it gives you those. LM, again, for linear model, parentheses, formula equals data dot frame. Not sure why it's called that. Parentheses, scale. Again, this is just, you can copy paste this code and not necessarily worry about why it's called all this. Parentheses, scale, parentheses, again, model, $model, that model term, that whatever you call your stuff here in the top line, model. You just make sure it's consistent with what you put down in the bottom line there. And then in those parentheses, and let's see what it looks like. Okay, so the primary output here is at the top so like if you are used to a one IV regression, well, you just had one line here plus the intercept. Now you have two lines plus the intercept. So what do we have? We have an intercept of 4.0039. That's our A value. Then we have negative 0.061. That's our B value, or our B1 for IV number 1, trait anxiety 7. Then we've got 0.128488. That is our B2. That's our B value or our slope for state anxiety, trait anxiety, number 9, second IV. So those values each have p-values that correspond. This is a weird format, but it's times, R is doing times 10 to the negative 1, which is weird. You just need to move the decimal point 1 space to the left. So in this case, it is 0.103 for the p-value. Not significant. So it's close, but it's not significant. Greater than 0.05. So the first IV does not have a significant impact on the DV. But the second one does. This one is times 10 to the negative 4, which means you got to move the decimal point 4 places to the left. So you've got 0.0001 in this case. Less than 0.05 for sure. So we're rejecting this null hypothesis and concluding that the second IV does have a significant effect or relationship with the DV. The first one did not, the second one does. Cool. All right. Then you've got some beta values down here at the bottom. Where are they? Okay, there they are. This is your beta value for the first IV. That's a 0.004. And then the second one is here, a 0.1. So those are your betas. You'll also see those in SPSS. That's it. At least that'll get you started. I mean, there's a lot of other things we can do with multiple regression. It's really cool. It's amazing stuff. And I'm just giving you a quick introduction to how to do it in R here. I hope you enjoyed.